So you have seen how to sketch a quadratic function using transformations. Now let's continue with the knowledge-based questions. Question number 2 is, state the equation of a parabola in any form that has a vertex minus 4, 5 and is thinner than y equals to x squared. So we could write an equation which is, let's say we can write this as y equals to, now when we say thinner, it means what? It means vertically stretched, right? So we could write, say, for example, 3 times, right? X, vertex is minus 4, 5. So x plus 4 whole square plus 5. So that would be thinner, right? So this value of 3 makes it vertically stretched. So basically we need vertically stretched graph. Is that clear? So that means a value is greater than 1. Now, question number 3 is, state the equation of a parabola in any form that has zeros 1 and 8 and is congruent to minus 2x squared. So congruent to this means the value of a should be minus 2. Then they are congruent. We are given the zeros, so the best form is the intercept form, right? So a is minus 2 and the intercepts at 1 and 8. So we have x minus 1 times x minus 8. Question number 4. State the equation of a parabola in any form that has vertex at this point and which passes through that point. So we may have to do some work here. Y equals to a times x plus 3 whole square plus 2. Now substitute this point to find the value of a. So we have 14 equals to a times minus 1 plus 3 whole square plus 2, correct? So let's continue. So in this, there's a small space. Let's bring this 2 on this side. So we have 14 minus 2 equals to a times minus 1 plus 3 is 2. 2 square is 4. 4a, right? 14 minus 2 is 12 equals to 4a. And that gives you the value of a as 3, right? So we get a equals to 12 over 4, so that means a equals to 3. Once we have this value of a, we can write down the equation, and the equation will be y equals to, a is 3 for us, and we have x plus 3 whole square plus 2. Clear? Question number 5 here is, find two symmetric points of the curve y equals to minus 2x square plus 2x minus 6. Now, symmetric points are the points which are same distance away from the axis. So the best symmetric points are, you find the y-intercept, right, and its image. So that you get in partial factored form, right? So when you write it in partial factor form, you get that, correct? So that is what is required. So I hope you understand the concept. So we can write this equation as y equals to, let's do partial factoring. So we can take minus 2x common, right? So from the first two terms, and we get x minus 8 divided by minus 2 is 4, right? And we have this as minus 9. So we have clearly 2 points here. And what are the 2 points here? If x is 0, then y value is minus 9. So one point is 0 minus 9, and that is your y-intercept, right? This is your y-intercept. Clear? The other point is, when I substitute 4 here, I get minus 9. So that is the other point for this particular function. Is that clear to you? Perfect. So basically, this will be a parabola which will open kind of downwards like this, since this value is negative. And you will notice that these 2 points are at minus 9. Correct? So let me just, the y-intercept, this is your axis. So this point here will be 0 minus 9, right? And this is at 0. And this point here will be 4 minus 9. Oh, sorry, 4 minus 9. Do you see that? So at 4, that will be minus 9. So that is how you are going to get your parabola, correct? So I hope this concept is absolutely clear. So these were 4 questions straight on writing the equation from the given information. Now let us take some application questions based on the properties of quadratic function.